Okay, so we ran out of time again, so let me pick up where we left off here. So I was typing in the square root of negative 31, and I got this result here. So I'm typing in the square root of negative 31, and I get that result. I get error, non-real answers. Now think about what a square root is. It's a number that when you square it, equals that. Well, is any number times itself going to be negative 31? No. I mean, 31 as a square root is between 5 and 6, but negative 31, 5 squared is positive 25, negative 5 times itself is positive 25. Any number times itself, any real number times itself is positive. So eventually in Algebra 2, you're going to learn about the complex number system and imaginary number system that allows you to take the square root of a negative. But in this case, we're not going to be able to take the square root of negative 31. So when you have that situation, right, that is not going to be possible to square root a negative number for a real solution. So caveat right there. So if that is the case, then it might be good news for you because that means you don't have to do anything else right here. That means that there is going to be no solution to our quadratic equation. In other words, if we graphed this equation right here, we graph it, we would see that that parabola never reaches the x-axis here. It has no roots, all right? And so what that literally means then in terms of our equation is it never reaches 0. The y value never reaches 0, and therefore there is no solution here. All right, the first solution would occur wherever that vertex would be. So if we could figure out what the vertex would be, then we get a solution. And anything above that, then we'd have 2 solutions. But anything below the vertex, including the x-axis here, is going to be no solution. Okay, so to summarize, how can we tell if we need to use the quadratic equation just by looking at the equation? All right, so we need standard form. In other words, ax squared plus bx plus c equal to 0, and an a value other than 1. So an a value right here, if that's 1, we should be able to use the complete the square. Completing the square might be easier, but if this is some value other than 1, then quadratic formula may be the best way to go other than graph.